This lesson will focus on writing equations for lines.
Okay, we might be given this line here and be asked to make an equation for this line. Our first step will be to make a function table. So I will go ahead and do that where we have x-coordinates and y-coordinates. There's our function table, and I'm going to take a look at some of those points that are on this line. I'll choose some points that are on this line. I've highlighted 3 points that are on that line. One of those points is the origin at 0, 0. Then we also have the point 1 that goes with 2. And finally, we have the point 2 that goes with 4. Now that I have 3 points, all I need to do is to find an equation or a rule that will hold true for each of these points. What we do is we think of how we can get the y value from each of the x values. In other words, how we can get 0 to 0 here, or how we get from 1 to 2, or even from 2 to 4. To get from 1 to 2, we could have added 1. However, if we did that with the other ordered pairs, 0 plus 1 would not give us that there. The other way we can get from 1 to 2 is that we can multiply by 2. So, if we multiply by 2 there, we get 1 times 2. That actually does hold true for each of those other points as well. So what we're doing is we're multiplying x by 2, so y equals x times 2. Or you can rewrite it as y equals 2x. And y equals 2x is going to be our equation for this line. This is our equation. This is what holds true. And then that's our steps there. So our second step again is to find that equation where each of those values that are in our function tables will hold true. Let's see another example. Okay, given this line right here, I'll go ahead and first make my function table. And I look at the point 0, and this is where it intersects the y-axis. That's at 0, 3. Where it intersects the x-axis, that is at 1, 0. And finally, when x is 2, it looks like y is negative 3. Now you'll notice that this goes from 3 to 0 to negative 3. And then what that means, since x is going from 0 to 1 to 2 is going up by 1, that means we're going to multiply x by 3. And then we have 3x there. Now, 1 times 3 is not 0. But if we know it's 3x, all we would need to do is to subtract, like this here, 3 minus 3x. Because this will be our equation that holds true, where y equals 3 minus 3x. If we look at 0, 3 minus 3x, 3 minus 3 times 0, that does hold true. Now when we put in 1, 3 minus 3 times 1, 3 times 1 is 3, and 3 minus 3 is 0. And finally, for x equals 2, 3 minus 3 times 2, 3 times 2 is 6, so 3 minus 6 is negative 3. So this equation here does hold true for this graph and for this line. Here I have another line. I'll make that function table. When x is 1, y is 0. When x is 2, y is 2. And when x is 3, y is 4. Now you'll notice here that I did choose values of x, where it is that x went from 1 to 2 to 3. I could have even chosen 0 there, and then I would have known that x is 0 when y is negative 2. You'll notice here that these all go by increments of 2, which means that we will be using 2x in one way or another. Now our other point here where it is that helps us is when x is 0. When x is 0, y is negative 2. So we'll know that negative 2 is involved in this equation somehow. Now it could be that negative 2 plus 2x equals y is our equation. Let's try that. X is 0. Negative 2 plus 0 does equal negative 2. When x is 3, 2 times 3 is 6. 6 minus 2, or 6 plus minus 2, is 4. When x is 2 here, 2 times 2 is 4. 4 minus 2 does give us 2. And when x is 1, 2 times 2 is 2, plus negative 2 is 0. Now another way we could have written that is 2x minus 2, y equaling 2x minus 2. And that's our equation for this line. Here I have the function table, and I'm asked to write the rule or the equation for this line. So I have the points 0, 4, 1, 7, and 2, 10. From 4 to 7, and then to 10, you'll notice this is going from 0, 1 to 2 already. This is plus 3 each time. Knowing that this is plus 3 each time, I know that I'm working with y equals 3x in one way or another. I know that y equals 3x is part of my equation. If I plugged 0 in for x, I'd get y equals 0. But I know that y has to equal 4. So I can do one more thing here. I can write a plus 4 in there. 1 times 3 is 3, plus 4 does give me 7. 3 times 2 is 6, plus 4 does give me 10. So this is my equation for that line. That's the rule that has to hold true. Here's another function table where we're asked to find that equation. And again, we'll do something similar in that we'll notice this is 0, 1, and 2 again, meaning that we can look for a pattern here. Going from one to the other, it looks like we're adding 2 each time, or we're going up by 2 each time, meaning that we have to have 2x somehow involved in our equation. Finally, if we say y equals 2x, if we want y equals 2 times 0, that'd be 0. How do I get to negative 3 from there? Looks like I would just go ahead and subtract 3. Let's try that. 2 times 1 is 2, minus 3 is negative 1. 2 times 2 is 4, minus 3 is 1. Here's my equation, y equals 2x minus 3.